Cognitive manufacturing in action, enhancing efficiency and maximizing performance with IBM Watson IoT for manufacturing. Leslie is a UAP manager. She isn't yet aware, but she's about to face a major production issue. Leslie's production unit benefits from a new type of solution. A solution connected with production equipment, leveraging the industrial Internet of Things, aggregating the massive amount of data generated by manufacturing operations from sensors, applications, documentation, collaborations, a solution that provides new ways to interact with using natural language processing, a solution that is able to learn from experts and from the history of all manufacturing operations, and thus enhance Leslie's decision-making. What does it mean to learn from manufacturing experts? Let's look at an example. Visual inspection. This expert is training a visual inspection system to assess the conformance of produced parts. This new type of solution is called cognitive manufacturing. The production issue faced by Leslie occurs when a quality problem is detected on the assembly line by the newly trained visual inspection system. Leslie is notified about this quality issue in her production monitoring tool. Her tool provides monitoring and predictive capabilities which help track equipment performance, anticipate potential problems, and provide recommendations to deal with those risks. However, since the solution was not yet trained for this type of issue, no proactive recommendation could be delivered this time. To further investigate this quality issue, Leslie begins a conversation with Hypexia, a cognitive chatbot understanding natural language.
Hi.
Hi, my name is Hypexia. How can I help you?
Hypexia, we must react to a quality alert on T9. Door panel inserts, front, left and right.
Where were the parts produced?
Today around 10:30 a.m.
This tool is still in production on machine 1300 tons number 5.
Okay, we must stop the production and isolate the shop stock area concerned until we understand the problem.
Understood. I'm notifying the supervisor now.
Hypexia, the problem is the distortion. Any data on what may have caused this?
Since NAFI material is being used, temperatures are known to be the root cause of distortion in 85% of cases.
Okay, what is the status of temperatures on the current process?
Temperatures in the screw and hot runner are stable and within tolerance.
Hypexia, can you detect any other abnormal parameter?
There is a very slight increase of TCU water output temperature, still within normal tolerance, but not stabilizing.
What is your estimated resolution time for this type of issue?
70% of the time with TCUs, time to repair is 3 hours, minimum is 1 hour, maximum 6 hours.
Hypexia, please urgently inform maintenance to check this equipment.
Okay, I am doing it right now.
Hypexia, what's our stock situation before stopping the assembly line?
Making the assumption that our entire shop stock is knock, our safety stock can still support assembly for 6 hours.
Right, it's too risky. Can you give me a solution to produce parts on another machine?
Comparing real trend of assembly line against PDP and backup machine, you can stop production on 1300 ton number 3 and switch over to T9 door panel inserts front for a double batch, then resume normal sequences starting with the next batch of production if the TCU was the issue.
Please notify the supervisor to engage this plan and update the SMED board.
Okay, doing it right now.
As an outcome of this conversation, Leslie decides to stop the production of the failing product, to modify the production schedule, and to request further investigation and maintenance on the issue encountered. A work order is now placed to the maintenance team. To accelerate and secure her decision-making regarding the new production planning, Leslie is assisted by a planning optimization tool. She can evaluate the impact of the new plan on other productions, taking into account inventory levels, assessing possible scenarios, and selecting the best optimized crisis planning. Leslie then publishes the optimized crisis production planning. After 30 minutes, back to the production monitoring tool, Leslie observes that the production level is still sustainable despite the production stoppage for the defective product. Meanwhile, Nicholas, the maintenance supervisor, is already on the job. Nicholas begins problem investigation using a 360-degree maintenance view. This view aggregates information from internal and external sources, maintenance logs, QRCIs, technical documentations, etc., and provides access to Hypexia, the cognitive chatbot. Nicholas explores this situation, also making use of Hypexia.
Hi,
Hi, my name is Hypexia. How can I help you?
Hypexia, where do we stand with our schedule?
Out of all our alerts, the most threatening we have at the moment is T9 door panel inserts distortion. Do you want to start with that?
Yes, so what can you tell me about it?
Among the usual causes for distortion, I've identified an abnormal behavior of the TCU.
Which TCU?
The TCU controlling the cavity side on machine 1300 ton, number 5.
What abnormality?
After tool change, the TCU water output temperature never stabilized, although within normal tolerances.
What main cause do we have in our record?
In 75% of the cases, the water input filter was clogged. Cleaning frequency was set to every 3 months. Since this TCU was serviced 80 days ago, I recommend an immediate unplanned service.
Okay, please inform the injection maintenance technician.
Doing it right now.
The important next step is that Leslie and Nicholas are going to feed the cognitive manufacturing solution with all the information gathered during this crisis so that it can learn from this experience. Should a similar crisis arise in the future, the cognitive solution will thus help the local site apply the learnings from this experience, and more importantly, this cognitive knowledge will be leveraged across the global company for a better manufacturing performance. This scenario makes use of several solutions from IBM Watson IoT for manufacturing. IBM Plant Performance Analytics to monitor production KPIs and alerts, predict issues, and propose recovery actions. IBM Watson Visual Inspection for Quality to detect product defects through cognitive deep learning. IBM Prescriptive Quality to monitor, detect, and predict product and process quality issues. IBM Maximo to plan and execute maintenance and repair operations. IBM Cognitive Equipment Advisor to identify the best issue resolution scenario based on unstructured information such as repair manuals, previous repairs, knowledge databases.